Alright, in this video we're going to look at antiderivatives and indefinite integrals. So before we look at the antiderivative and indefinite integral, we're going to go back and review over derivatives. Because in order to understand what antiderivatives are and what indefinite integrals are, you need to understand what it means to take the derivative of something. Say we have this d over dx, which is the same way of saying take the derivative of, let's start off, let's say x squared. Now we know that this is a simple derivative, and if we took the derivative of this, we would get 2x. Now let's say if we are taking the derivative of, again, of x squared plus 1. We know that this is going to equal also 2x. The derivative of x squared is 2x, and the derivative of 1 is 0, so it's just 2x. We also could have something like this. Take the derivative of, x squared plus pi. Now if we had this, it's also 2x, because you're taking the derivative of x squared, which is 2x, and the derivative of pi, which is 0. Sorry about that mark there. My hand kind of slipped. And basically, what all these functions come down to is saying that the derivative of x squared plus a constant will always equal 2x. Now the constant has to be in respect of c. You know, it can't be another variable, but in respect to x, it will always just equal 2x. Now let's look at antiderivatives. Derivatives. Now basically what antiderivatives is asking this question. Let's just say we take the example from the previous slide. It's basically asking what is, here would be the function. So on the last slide we're going to use 2x. The derivative of. So basically we're asking this question, what is the function, in this case 2x, what is 2x the derivative of? Well, we know that the derivative used to get 2x were x squared plus 1, and as well as x squared plus pi. So in a general sense, you have x squared plus a constant equaling 2x. Now this is what we call the antiderivative. But we don't want to say this sentence all the time, so we have to use connotations to figure out, to give directions to take the antiderivative of. So there's a way of writing it using connotations, so this is how we do it. This funky looking fs thing, and dx, and then the function goes in between them, and in this case it's 2x. What is the antiderivative of 2x, which is 2x? Now in this connotation here, this symbol here and the dx act as parentheses. You could think of it that way. But it's basically asking what is the antiderivative of the function here in the middle, which is f of x. You can think of it as f of x. What is the antiderivative of that in the middle? and we find out that it's, of course, x squared plus a constant. We use the constant here because we want to cover all bases. We want to make sure that it also includes any number, given that there is just one variable x. We want to cover that it could be pi, it could be a number, so that way we don't get confused. So to end this video, remember, this here means what is the indefinite integral. If I could spell, that would be great. Integral or antiderivative.